Really add that detail there, Danny. I love that.
Okay. Let's roll. Let's roll. We left off on number 58. Now, let me tell you, I don't think we're going to have time to go over every single problem. So choose your problems wisely. Choose your problems wisely.
All of them.
We're not going to have the time to do all of them, so choose them wisely. Haley, all of them.
What page are we starting on?
Well, we left off on 58. So
Let's start with doing how we do 2 of the Hess's law, and then we can pick and choose some of them.
Each subject area.
I agree. We should do 1 of each subject, but I don't know when.
you guys pick.
Hess's law.
All of each.
All of each subject. Wait.
So you want to start on 78?
Let's do 61.
What do you mean?
61?
Wait, what does 61 do?
Yeah, agree. The stuff we've already done.
61. Page 61.
Really?
No.
Yes.
No, hang on. I have the, yeah.
61.
Yeah, 61.
61 says a 5-gram sample of aluminum pellets and a 10-gram sample of iron pellets are heated to 100 degrees Celsius. The mixture of hot iron and aluminum then dropped into water. Calculate the final temperature of the water and the water mixture, assuming no heat loss is gone to the surroundings. So this means that Q lost by AL, agreed? Plus Q lost, what else did we mix with that? Iron, Fe, should equal heat, should equal Q gain by H2O. So this is essentially SMAT plus SMAT equals SMAT. Right?
Okay.
That's what we're doing here. Yes? So aluminum, they said that I had 0.89. So 0.89 joules per gram degrees Celsius times, I've got, what mass? 5 grams? Times 5 grams times 100 minus TF. Agreed? That would be that. So that whole thing, plus, now I've got to go to iron, which iron is 0.45. So I should probably do something like this. 0.45 joules per gram degree Celsius times iron's mass is what, 10? Times 10.00 grams times iron is going to go, once again, from 100 minus TF. So that whole thing has to equal SMAT water, right? We know the water specific heat is 4.184 joules per gram degrees Celsius times the mass of water is what? Did they give that to me? 97.3 grams. And the water was at 22, right? So this one would be, what would I put here? It would be TF minus 22. Then you would just do algebra from that point on. You would do algebra and then have to solve for TF. So you have a lot of multiplying through, adding, all that stuff. Oh my goodness, you are the best.
You did it.
I told you guys, Salvaji always comes through. Always.
Salvaji, we heard you got proposed to in front of a periodic table.
I did.
Yes.
When I moved classrooms, I brought it down there with me.
I told them.
It's kind of a big deal.
Yes, I told them when you retire, you're taking it with you. Oh, those are so good. It doesn't matter. Thank you so much. So good. So, what's your, anybody solve it? Did anybody solve that?
Wait, I did this.
No one did?
JK, I totally didn't do it.
No one solved it?
No. 23.7.
Yep. You end up with 23.7 degrees Celsius. So once you do all that algebra, it's 23.7 degrees Celsius. Next one.
Can we please do Hess's law?
Sure. You want to skip to a Hess's law?
We can come back.
We could come back. 78? Let's do it. It is. 78. So on 78, what I like to do is I like to write down what I'm going for, right? I want to make sure I give myself enough room. So I am going for ClF gas plus F2 gas yields ClF3 gas. Are you guys okay with that?
Are they, is it ever gonna, oh wait. It could have 2 on both sides, right? Because I remember that's what we did in the note.
Sure could. Sure could. So, let's see. What can I isolate first? F2. Only one equation has F2. Agreed?
Yes.
Which one is that?
Last one.
The last one. So let's start with that one. So I have 2 F2 gas plus O2 gas, and that yields 2 F2O gas. And that gives me an energy of negative 43.4 kilojoules. But I don't need 2 F2s. How many F2s do I need? 1. So what do I have to do to everything in this equation?
Divide by 1, 2, and half.
Divide by 2,
Okay, cool.
divide by 2, divide by 2. So what do I have to do to my energy? Divide by 2. Divide by 2. So once I do that, I have 1 F2 here. I have my F2 gas. That's good. We're good with that.
Wait, so I'm
Yes, yes,
confused. You're trying to like,
I'm trying to,
are we gonna use all of these?
yes. You will always use all of them.
So you're gonna use all of them and you're gonna,
One of them is probably just going to be to cancel out stuff you don't need.
I'm confused on what the,
does not matter, right?
Order doesn't matter.
I'm confused,
Yes.
I'm confused on what the end goal is.
The end, this is my end goal. I write down what I'm trying to get it to.
Is to get that.
Yes.
How do you know you're trying to get that?
Because they told us. I need to figure out delta H for this reaction.
You're making a giant equation in order, and you're just using the stuff on the inside.
Okay. Next one. I need CLF on the left. Is there an equation that has CLF on the left? Top one. So I have in the top one, I have 2 CLF, which is the gas, plus O2, which is a gas. That yields Cl2O gas plus F2O gas. And that has a heat of 167.4 kilojoules. Do I want 2 CLF though?
No.
No, so what do I have to do?
1. Divide by 2.
Divide by 2, 1/2, 1/2, 1/2. This turns into 1, so I now have CLF on the left.
These are a lot easier.
Wait, so
than I
are
remember
you
them.
dividing the?
What?
Kilojoules.
Yeah, that.
Are you dividing the energy by the two?
Yes. So, divided by 2. Divided by 2. We good so far? Now, I only have one equation left. So I know if I do this correctly, this should all work out. Right? I need CLF3 on the right. Do I have an equation with CLF3 on the right?
Yeah.
No.
No, you don't.
That's why
Do it
you
on the
flip
left.
it.
But I have one on the left. So I have to take the second equation, I have to
Flip it.
flip it. So the second equation is Cl2O gas plus 3F2O gas yields 2ClF3, which is a gas, plus 2O2, which is a gas. Energy of that is flipped, so that's negative 341.4 kilojoules.
Are you always, question,
Yes.
are you always going to have one that flips? Or not necessarily?
Not necessarily.
Okay.
Still.
Because it's,
Yeah, so I only need one. CLF3. So, divide by 2, divide by 2, divide by 2, divide by 2. So divide by 2.
You notice that all of them will double our final result? Could we multiply our final result?
You could. I talked about that when I taught this. What you could have done, you could just double, 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 right? And then at the end, divide your energy you get in half. You could do that as well. So now I have CLF3, CLF3. We got to make sure everything else cancels out though. So let's check it. 1/2 O2 plus 1/2 O2 is how many O2s? 102. Do I have 102 on the right to cancel that out? Gone. I have 1/2 Cl2O and I have 1/2 Cl2O. Does that cancel out?
Yeah.
Sure does. I have 3/2 F2O and I have 2/2 plus 1/2. What's 2/2 plus 1/2? That cancels out. That's good. Add everything up. Add everything up, and what do you get for your energy? That's what I got. I got negative 108.7 kilojoules. Questions on that?
Okay, I'm really confident.
You want another one of those, or what do you want next?
I'm feeling good on those, so let's do some of the other ones.
Okay.
Can we go back to like,
My shoulders hurt so bad.
What do we want?
let's go back to one of the other.
You tell me.
I saw the clip.
Ew.
You're a sucker. You made me throw it away.
Maybe 64, 69.
Let's try 67.
67? All right. We have consensus on 67.
Sounds great. Wait, 67 was one of the, oh, my bad.
What?
I said 77.
No. It's not. 67.
Do it.
Coffee cup calorimeter. We got water at a temperature. Potassium bromide is added. After KBr dissolves, it goes up. It gets hotter. Calculate the enthalpy change for dissolving salt in joules per gram and kilojoules per mole. Assume specific heat is 4.18 for the solution. And that no heat is lost to the surroundings or the calorimeter. So 67. I know that Q equals SMAT. Agreed?
Is there a question?
Yeah.
Is there any, like, is there ever any, like, little hints in a question that tell you to do QSMAT?
I mean, when you're figuring out enthalpy, I mean,
You're probably gonna have.
or if you're given like a specific heat or something in joules per degree Celsius.
Is it like the Pivner of this chapter? Like,
Yeah.
when in doubt, you would probably use it.
I mean, you're going to use this a lot. You may have to use Pivner on the test too. You never know. Just Pivner at everything. Yes.
Pivner everything, when in doubt,
No
Pivner.
matter what you do, even if it give you a specific heat, Pivner.
Yeah, yeah.
Yes. Right.
You should get 5 points for everything.
So I've got 4.18 joules per gram degree Celsius. Do I have a mass of water?
Yes, 10, oh, that's 7.
No.
No.
But read the question. It said the specific heat capacity of the what? Of the solution, which you would agree is water and the potassium bromide together. So what is the mass I'm going to use here?
10.5.
Plus
125?
plus 125. You have to add the masses together because it's the whole solution. With sig digs, that becomes 136 grams.
Wait, and is this just for the water?
This is the whole solution.
Oh, we're finding it in the QSMAT.
It says, assume heat capacity. The question is calculate the enthalpy change for dissolving the salt. And they're giving me the heat of solution, right?
Okay.
So I have to add it together. 4.18, 136. My temperature change, it went from what to what?
24 to 21.
24 to 21. So what's my temperature change? 3.1 degrees Celsius. We good with that?
Yeah.
Okay. So Q equals, I got 1,760 joules. Now, they asked me for it in joules per gram. Okay. Well, divided by, It says calculate the enthalpy change for the salt. So what's my mass of salt? 10.5 grams. So that's going to give me joules per gram, agreed? So I got 168 joules per gram of KBr. And I also wanted kilojoules per mole. So I'm going to take my 168 joules per gram and do a little bit of stoic. I know that for every 1,000 joules, there's 1 kilojoule. And there is 119 grams of KBr in 1 mole of KBr. Joules gone, grams gone, leaving me kilojoules per mole. So on 67, I got 20.0 kilojoules per mole of KBr. So the key to this one is it was the heat of solution. If you're given the heat of solution, you've got to add your two things together, the water and whatever you're putting in it. That was 67. I'm glad we did that one. I'm really glad we did that one.
Me too.
I'm super glad we did that one. Audrey,
Would this be considered
what?
this direction would be considered
Well,
I'm super mad.
did it get colder?
Little bit. No, I'm not.
Yes. That would be endothermic.
Guys, I'm so glad.
Yeah.
Okay.
Yes.
We get it.
Oh, 67 degree on the planets.
Danny, how slow can you get?
Maybe, why are you just guessing over here?
Or something like that.
We obviously know what it is.
Something similar.
Everyone put a star by that question.
I did.
Just so you can look at it every day.
Audrey,
Just one day.
I just had one question, it was over 65.
what about it?
I think my confusion was also at the end of exothermic, because I don't quite understand why it would be considered exothermic.
So on 65, it was at 22.6 and it ended up at 23.4. So if the water got hotter, right,
Oh, so it's really,
it's releasing heat.
gotcha, so that one should be an extra,
Correct.
even though the change in temperature.
So here's my 65, right? 65, I got negative 66 kilojoules per mole.
I got the 66 still.
But that'd be negative.
So even though delta T in that scenario is technically positive,
Uh-huh.
it's still, you just have to look at it.
Yeah, you got to just kind of look. You can kind of do absolute value of your temperature change as long as you know what's happening. As long as you know what's happening.
Oh, yeah.
Yay!
Wait, yeah, I want to see.
What'd you say?
You do the ASMR?
Oh, this is.
Yeah, do the
I thought Haley said, I want to see you eat your food. I'm like, that's weird, Haley.
I want to see how to do this. Sorry, guys.
ASMR, real alert.
Super weird.
Stop.
I just have a hard time like knowing what to do at the beginning.
Wait,
You
so why don't
just
we
do
do
a
this?
starter.
Why don't we do this 1.184?
Okay,
Because-
I just kind of got confused how to like what order, but
Once again, this is the heat of solution. 4.184 is the specific heat of water. This is talking about the solution. It's pretty much water, but you have something dissolved in it. So it's a little bit different. It's a little bit different.
Is AGNO3 and A, wait, what is that? AGCl, are those like 1-to-1 ratio then?
On 65,
Yeah.
yep, it's 1-to-1.
I love when I ask a question and then it's right, because I like know what it is. It just makes me feel smarter.
I'm happy for you.
Thanks.
I'm definitely happy for you.
I just like the last step I got. It's like
Yeah.
I did the wrong thing, but like I have.
So I got 330 joules per mole, but I wanted kilojoules per mole. So this last step is kind of the same last step I did here on 65.
Okay.
All right, what's the next one? We got some numbers pretty high too. Want to get into the high ones? What?
Aren't those all Hess's already?
No,
Then let's do it.
I don't think so.
About 64.
64.
65?
64 is right here. That's just Q lost equals Q gain. So SMAT equals SMAT.
So wait,
Like,
so
how do you
when it's Q loss and Q gain, does that mean there's multiple SMATs that equal SMAT?
Yeah, it's a SMAT equals a SMAT. This is exactly what we did in lab, right? 64, they're asking for what, but they're just asking for the mass of water. So on this one, you have everything but your mass of water. You're solving for X. SMAT equals SMAT. Cool? I will start eating my double cheeseburger, which looks so good. Best sandwich at McDonald's.
No, chicken's better.
Didn't they make like a giant chicken nugget sandwich or something?
Isn't there like a chicken
Big Mac.
Chicken Big Mac.
Big Mac?
I feel like you would get that with
I don't know about that. I would hope you want.
What's the appropriate amount of bites to eat a double cheeseburger in?
4.
It's looking like between 4 and 5 for me. I'm just starving.
I would say 5. Because you want to enjoy it more than 4, but 6 is too excessive.
6 is really taking your time.
But also, like,
It's not worth 6 bites.
the size difference of a good burger at like Longhorn versus McDonald's and like the price is like,
Yeah, but McDonald's has the chemicals that make you feel good.
Yes, that's what we want.
I'm just saying. When's the last time you left McDonald's and didn't feel happy? You don't. You feel happy.
Every time I eat a large fry, I feel a little bit better.
No,
Oh, that's 3 bites.
Like that's all up to
That is 3 bites.
I asked for sweet tea
I
and
love
it's like
that, and
half
it's
sweet,
yellow.
half unsweet.
And
It's
it's
like
sweet.
gross.
make me a lot.
And then we couldn't even go back.
I like the little slushies. I don't even know what it's like. I like gas station slushies, but you don't have to go to the gas station.
Yeah.
Did you guys see the thing about the McDonald's ice cream machines?
They're always broken.
So, do you know why?
Because they're right.
No. So, McDonald's ice cream machines are owned by a specific company, and that company cannot fix them fast enough. They have a monopoly on these machines. McDonald's took them to like the Supreme Court, and the Supreme Court ruled in McDonald's favor that they can get these ice cream machines fixed by other companies now.
Wait, I'm so confused. So wait,
So the ice cream machines that McDonald's has were only allowed to be fixed by the company who made them. So it was like a monopoly. So the Supreme Court overruled that and said, can't do that. So now anybody can fix the ice cream machines at McDonald's.
Is the name of the kids like McDonald's the
I have no idea, but
McDonald's versus
I have no idea.
versus ice cream?
Why don't we study that?
All right. See, that's interesting. That's how I would teach Gov.
Election day, we already talked about it. He was just like, yeah, guys, election day, and that was it.
Okay.
Okay.
Like, you're a drug teacher, why aren't we doing
Results of all like the local ones.
And like, we have,
Presentations that we're doing.
like, you write like a little contract and everything. You just like,
I actually feel like
It was like 5.5.
like, I wrote it. They literally are still
All right, next one. We got work to do.
What?
That's too much.
Is it just this?
All right, next one.
What is the next one after a Hessen's law? After like,
After 78.
or is the very next one of?
So we got 78. 81 is a Hess's law.
Okay, we don't need another Hess.
We got 82 is a Hess's law.
Hess's Law. We're good on Hess's Law.
Maybe if we have 5, can we get one more?
Yeah. 89 is a delta H. That's just where you use the back of the book. Do you want to do one?
Yeah.
Okay.
Wait, do we get the back of the book?
Yeah, I will give you what you need.
Wait, what does that mean?
So I want to know, like,
Remember the chart in the back of the book with the delta H, the bond energies?
I want to know how to like utilize it though, like.
Let's do it. We're doing 89.
I don't know, I can't wait to like. But I kind of eat, guys. It looks like ever more brain vibes. Do you want me to?
I don't know.
I do need to log in. I do need to log in. Yeah, I'm gonna log in.
All right, here we go.
The burger ASMR.
89.
What number?
89. The reusable rocket boosters of the space shuttle use a mixture of aluminum and, ammonium perchlorate as fuel. A possible reaction is blank. Calculate delta H. So do you guys remember that chart in the back of the book? So it's in the appendix somewhere.
Are we gonna have to like go back there and find it?
No, I'm gonna print out what you need on the test.
I love that. Thank you, Mr. Heller.
I'm gonna print it out. So 89, the balanced equation is 3Al solid plus, wow, that McDonald's is sitting heavy.
I can tell in your voice.
3NH4 ClO4, like a good heavy though. Solid.
Are you happier now?
I am happier. I feel happier. Yields, oh my gosh, why did we pick this one?
I just was thinking that as I was writing down.
Al2O3 solid plus, no, it's just going to be a lot to write. AlCl3 solid plus 3NO gas. And guys, the states matter, right?
Yes.
Oh my goodness.
Plus 6H2O gas.
I'm not gonna be able to this.
It says AL something O2.
Al2O3.
Oh, okay.
So remember,
Can we zoom in?
probably. Remember,
Number one off.
delta H equals sum
Yes.
of what minus what? What?
Aluminum and ammonium.
Products
Oh, okay.
minus the sum of reactants. So delta H equals, first product is
Ammonium, aluminum.
1 mole of Al2O3 times, I would then have to look up Al2O3 in the back. So Al2O3 is what?
I should have started this.
Negative what?
I should have started this on this paper and just.
Negative 1,676, 676 kilojoules per mole. Plus, let me zoom in a little more. Negative 1,676 kilojoules per mole. This is from the back of the book. Plus, now I have to do AlCl3. I have 1 mole of AlCl3. And AlCl3 is what? Anybody? Joe? Negative 704? Negative. Plus
You just gotta up the octave and then you can't tell.
3 moles of NO. What was NO's number from the back, Joe? 90.
Whoa.
Times 90 kilojoules per mole plus
Wait.
6 H2O. So 6 moles of H2O times, what was H2O's? What was it? Negative 242? Negative 242 kilojoules per mole. So all of that added together. That's products.
Is that
How did we
it for
get all
the?
of this?
This is just the coefficient in front of it times the number in the back. The coefficient in front of it times the number in the back.
It's okay.
Coefficient is 3 times the number in the back. Coefficient is 6 times the number in the back.
Is that okay?
Oh,
Okay?
so it's, the back is the AlCl.
Yeah, you'd have to just find it,
Yeah.
which I'm going to give you a chart on your test. Okay?
Hey, is this one that's, we're really glad that we have one, like that we're really glad that we're doing?
There's really only, I mean, if you look at the review sheet, right?
Is there
The review sheet has 4 problems. There's more than 4 problems on the test. All right? But that's going to give you an idea of like the types.
Okay.
It's going to give you the idea of the types. Minus reactants. Here's the nice thing. What is my heat for aluminum solid? Zero.
Oh, because it's by itself.
It's elemental. Elemental has a charge of 0. So I only have one thing to subtract, right? So minus 3 moles of NH4ClO4 times, and that one is negative 295 times negative 295 kilojoules per mole. Just make sure you do your math correct. Make sure you do your math correct.
I know, that's literally where I struggle.
Dude, now I kind of. Did you see that Burger King is coming out with like an Addams Family meal?
They already have the SpongeBob
Yeah,
one.
like the. No, that's Wendy's.
That was Wendy's. I heard that the Krabby Patty was disappointing. That's what I heard. Danny.
So wait, why don't you do 3 a.m.?
Elemental form is 0.
Oh, right.
Just like our oxidation numbers, elemental form is 0. There's no bonds to break. No bonds to break, no bonds to make. Joe, what'd you get for 89? That's what I got. Negative 2677 kilojoules equals delta HF at standard conditions.
That's beautiful.
So that's 89. That's also 90. That's also, it's also 91. Now, notice 91's a little different, right? How is 91 different?
You're finding out CL.
Oh, so I've given you the final answer, and you're solving for one of the originals. So you're just like you're solving for X.
So is there and then divide it?
What? On 91, it's the same as this, right?
Yeah.
Except for you're given the answer, and you have to solve for
But how do you
one of
go
them.
backwards like that?
what?
How do you
You
find
just like
that?
instead of one of them, just put like an X or something.
So I would just go in, like, if I was doing it with this one, like I would have the answer, I would just make that X and solve for X.
Oh, wait, so you have that whole thing and you have the set that equal, and then you solve all the small things that you can, and then
Yeah.
you subtract it over.
Just solve for what you don't have. That's the only reason.
So, the reason why we only have one of the reactants is because AL like doesn't count.
That's elemental form.
So it doesn't.
If it is elemental form, 0.
I remember that in the notes now.
Yes, I did talk about that.
On this, you would only.
Oh, I
Wait.
see. It took me a second, but I.
Yes,
What if both on this side are elemental?
then that's your answer. There would have been nothing to subtract. It's minus 0. Joe. 92.
Wait, what?
92? Let's do it. So, 92. Here we go. 92. 92. I have the standard enthalpy of combustion of ethene
Oh, I just hit my funny bone.
is, are you okay? Negative 1411 kilojoules per mole at 298 Kelvin. Given the following enthalpies, calculate delta H. Joe, did you write a balanced equation? Yeah. So ethene is C2H4 gas. If you're combusting it, what am I always adding to that? O2, which is also a gas. And that always gives me CO2 plus H2O. CO2, which is a gas.
Why are we writing this?
We have to have a balanced equation if we're going to solve our delta H, right?
So if there's delta H, you want a balanced equation, like, because you're gonna have to take all the.
H2O, what form is my H2O in? That's actually a liquid, all right? Like if you would put a, like a watch glass, you could see the water, like liquid form. Okay, is this balanced? No. So I need to put, I got 202, I'm gonna have to double this, right? No. 2H2, what if we double here? 2 here, 2 here, 3, does that look good? Yes? Okay. And they are telling me that negative 1411 kilojoules per mole equals the sum of my products minus the sum of my reactants. Because they gave me the enthalpy of combustion for the whole equation. Kind of what we were just talking about, right? They gave me CO2. Oh, wait, I'm on the wrong one. Wait, no, I'm not. And they gave me H2O. So they have saved some work for me. So let's sub in what we got. Yes.
I love that.
Did you guys know that this was written by lovers, this book? Have you ever looked at the names of the authors? It's Zumdahl and Zumdahl.
Oh, that's so cute.
It's the cutest thing ever.
I saw this one post.
Cutest thing ever.
And then there's they come.
Mr. Heller.
Yes.
I saw this one post once. It was these two people like writing a book, and it was like two different people at first, and then they were married in the second edition. It was like the same name, but all of a sudden they had the same last name. in the
Yes.
second edition. I was like, that's so cute.
And there's these two people at AP grading that are like probably the same age, and they're married. And I always imagine, like, when I go to AP grading to grade AP Chem, I imagine them as Zumdahl and Zumdahl. They're not, but that's who I imagine.
Aw, that's
So,
funny.
yeah,
Wait, is this made for AP? Yeah, it is.
specifically for AP Chem.
Period.
In fact, I picked this book. I picked this book. Well, no, I picked it because I went through the book adoption, and
Oh, I would have.
I was in charge of AP Chem.
There's romance. That's so fun.
negative 1411 kilojoules per mole equals, here we go. I have 2 moles, here's my products, of CO2 times, they gave me CO2, right?
Yep.
Negative 393.5. Negative 393.5 kilojoules per mole. Sum of this. Plus, they gave me H2O. 2 moles of H2O times negative 258 kilojoules per mole. There are my products. You guys okay with that?
Yes.
Minus. So given the following enthalpies, calculate delta H for C2H4. So it's just minus X. Because O2 is what? Elemental form. Because O2 is a diatomic. Minus X. So all you're doing here is solving for X.
I love the singles.
Is that helpful, Joe? Okay. Solve for X. And X, I got 52.5 kilojoules per mole. 52.5.
That one is like the backwards one, but it's just different because,
This is exactly what I was just talking about.
okay.
Where you would be given the delta H for the reaction, you'd have to solve for X.
I can
It's
do
almost
that.
kind of like, if you remember the average atomic mass question on like chapter 1, where I gave you the average atomic mass, you had to do like
You have to
X,
go back.
X minus 1.
Wow.
You don't want to do that here, but same idea. Same idea. Next one.
Let's go into like the hundreds and like.
Go to the hundreds.
What's after me?
Let's do one.
So 108.
Oh yeah. Yeah, we'll go to 108.
108? All right, I'm going to have to flip the page. Can I flip my page?
Yes.
Okay.
A little bit.
108. Wow, we're zoomed in here.
What I do like about the test questions is that I feel like sometimes for the homework questions, there's a lot of words in there that like try to like mess me up, and like there's just like a lot that like I don't actually need.
Well, this is harder. Remember, these are always harder than the test,
Yeah.
which is what I'm trying to do.
I like the parentheses at the end of one of these.
Yes, the parentheses. Never run this reaction. It's very dangerous to burst into flame. Except for they do this in CP Chem. Right?
Oh yeah, when she
Remember when we
told us-
dropped the potassium in?
No, Mr. Ruff.
Was that the period I did it?
No, Mr. Ruff could not get it till late, but then at one point he like threw it in and it like exploded.
Yeah,
I have like
yeah.
a video of like it like literally like almost.
Oh, you gotta go.
It was funny.
Yeah.
It was so funny because he kept throwing it in and it wasn't working, and then he was like so close to it, so he just assumed it wasn't gonna work and it just went.
I'm just writing out the balanced equation. Was 2H2O liquid. I'm dropping potassium in water. Yields 2KOH AQ plus H2 gas. This is the part that's dangerous. If that H2O gas ignites, that's where you're going to get your burst of fire. So I got a 5-gram chunk dropped into a kilogram of water at 24 degrees Celsius. What's the final temperature of water? Assume all of the heat is used to raise the temperature of the water. Yes, that's what I was about to ask you. You're going to be doing some kind of QSMAT on this. Before that, all right, 108 is asking me for what's the final temperature of the water. So the first thing I know I'm going to have QSMAT equals QSMAT. Agreed? So the first thing I'm going to do is I'm going to start out with my 5.00 grams of K. Potassium is 39.09 grams of K in 1 mole of K. And in my balanced equation, I have 2 moles of K for what?
Wait, why are we doing school again?
Why?
No, sorry, I was just
Hold on. Did we skip a step? Oh, you know what we would had to have done first? The first thing we would have had to have done is figure out the delta H for this whole reaction. Like what we were just doing, right? So let's skip that, okay? Because we know how to do that now. You would have got the delta H, you would have had negative 390. Negative 390.
One of those problems that we just did.
Yes, you would have had to have done KOH minus H2O, right? Because that's elemental. Because that's elemental. That's elemental. So that gives you the negative 390 kilojoules per mole. So that's step 1, right? Now I know for every 2 moles of K, I have negative 390 kilojoules. And I know that 1 kilojoule is equal to 1,000 joules. Why am I trying to get this into joules?
Because you want to get.
Because I want to get to SMAT, right? And SMAT is not in kilojoules per gram degree Celsius, it's joules per gram degree Celsius. So this is going to give me my heat for the metal, the heat lost by the metal. So on that, I got negative 24,900 joules. And I know that my negative Q lost of metal has to equal Q gain of H2O. In other words, SMAT equals SMAT. Right? Grady, good with that? So, negative Q would be 24,900 joules equals SM triangle T of water. So 24,900 joules equals water is still 4.184 joules per gram degree Celsius times the mass of water, they said was what? Did they say a kilogram? That's silly. So make sure you convert that to grams, right? Yes. Times triangle T. Yes? What am I solving for here? Solving for the final temperature. So am I solving for the final temperature right here? No. I'm only solving for the change in temperature. So after I solve this, there's going to be one more step. Going to be one more step. So triangle T, what's the question?
I just feel like I don't know how, like, let me you keep going.
Okay. So I got for my triangle T, I got 6.0 degrees Celsius. I got 6.0 degrees Celsius. So on 108, they said that the water started at what temperature? 24. 24 degrees Celsius. Am I adding or am I subtracting 6? Adding, right? Plus 6.0 degrees Celsius. So the final temperature is 30 degrees Celsius. How did you know that you were adding it? It's positive, right? We know that the water should have heated up. So the step I did not show, Lucy, just to make sure, all right, is we would have had to done before this the delta H equals your sum of 2 moles of KOH, right? Minus your sum of 2 moles of H2O. That's how we would have got the 390. We just didn't show that step to save time.
But then what are you doing with like the 5 grams?
So I had to figure out the heat loss by the metal. Potassium was my metal because negative Q loss has to equal Q gain.
Okay.
So I used my potassium to moles, 2 moles to my heat, and I got my heat loss. Negative Q loss has to equal Q gain. The only way to get my Q loss on this one was by doing this first.
Okay.
That's why.
Got it.
And then you have to add at the end. That was 108. Next one.
You should do 109.
I figured that was coming. 109. The enthalpy of neutralization for the reaction with strong acid or strong base is negative 56 kilojoules per mole water produced. How much energy will be released when 200 milliliters of 0.4 molar HNO3 is mixed with 150 milliliters of 0.500 molars of KOH? Step 1.
The molarity, I mean the moles.
Before that,
Write
write a balanced equation. Write a balanced equation. So I have HNO3 plus KOH. The nice thing is, this is acid base, right? One of the products is always what? Acid base? H2O. So I have to figure out the other one, which is going to be KNO3 plus H2O. We okay with that?
Yes.
And they told me that that equation is negative 56 kilojoules per mole. So it's nice that they already gave us our delta H. You with me so far? Is that balanced?
Yes.
Yes. And they told me that I have 200 milliliters of 0.400 molar this, and I have 150 milliliters of 0.500 molar this. So what am I going to do? Figure out the limiting reactant.
Is there
Right.
if it's on the test?
I don't know.
Have you made the test yet?
It's like half made, half not made.
That's real. You just do what you want.
I kind of do what I want. But I'm like giving you hints
Okay.
as I go. So how I would attempt this is I would start out with my 0.200 liters. I converted that. You guys okay with me converting that to liters in my head? Of HNO3. And I know that for every 1 liter of HNO3, I have 0.4 moles of HNO3. Does that make sense where all those numbers just came from?
Yes.
And for every 1 mole of HNO3, how much heat do I get? Negative 56. Negative 56 kilojoules. Same thing, and that gives me negative 4.5 kilojoules. Same thing for part 2. 0.1500 liters of KOH times for every 1 liter of KOH, I have 0.500 moles of KOH. And for every 1 mole of KOH, I have, once again, negative 56 kilojoules. So that gave me negative 4.2 kilojoules. Which one's less? That's your answer.
That's the answer for everything.
That's it. Because 109 said, how much energy will be released? It has to be the lesser of the two. So I kind of ran this to kilojoules instead of taking it to moles first.
But you don't have to go down.
You could have taken it to moles, stopped there, and then still done this last step.
You just do 1 to 1.
Because it's a 1-to-1. Because it's a 1-to-1, you don't have to. You would have got the same thing either way. You still would have. I bet the book runs it to moles and then does a separate step when they run it to kilojoules. I don't know why they do that. I just like to do one step if possible. That was 109. 116.
Wait, this is a.
Oh,
Can we not do it?
let's skip to 132. Let's skip to 132, and then we can come back to anything else that we want to. Yeah, this is a good one to do. This one is
Guys, this is a good one.
involved.
Is this a really good one?
Oh, I think this will be kind of long for a test.
Oh, good.
Good. The sun supplies energy at a rate of 1 kilowatt per square meter of surface area.
I already hate this question so much.
So much reading. It's the reading. It's the reading. And one watt equals 1 joule per second. The plants in a field make the equivalent of 20 kilograms of sucrose per hour per hectare. A hectare is 10,000 meters squared. Assuming the sucrose is produced by the reaction, la-di-da-di-da, delta H, calculate the percent sunlight used to produce the sucrose, that is, determine the efficiency of photosynthesis. This is a lot. It's just good to do. No, I like to do problems like this. Here's why. It looks hard, but it's not that hard. Did anybody get this? Attempt this on their own. Will, did you get it? Do you think you got it? Okay. Anyone else? You can do this. That's the main thing, is I want you guys to know that you can do this. On 132, what would be the first thing I would probably need to figure out? I already have an equation. So it says calculate the percentage of sunlight used to produce the sucrose. The first thing I did is I figured out the energy needed. So my first step was to figure out the energy needed. So my energy needed, they told me that I have 20 kilograms of sucrose, right? How many grams is that? 20,000? Yes? That's 20,000, does that sound right? Grams of C12, H22O11 per hectare. Can we just call that an H?
Yeah.
Okay. I also know that for every 1 mole of C12H22O11, I have the molar mass, which is 342.3 grams. They also told me, I just added those up.
He just did that to his head.
I did that in my head, just like that.
Exactly. The McDonald's.
I also know, yeah, the chemicals are kicking in.
I can hear the voice.
For every 1 mole, see, I hit the low and now I'm going up. Yes. For every 1 mole of C12H22O11, they gave me the delta H, right? Which is what? 5,640 kilojoules. This is going to give me, grams are going to be gone, moles are going to be gone. That's going to give me kilojoules per hectare. So that gave me 3.3 chemicals are kicking in times 10 to the 5th kilojoules per hectare. So that's the energy needed. Now I have to figure out how much sun is the energy giving me. So my next step is energy of the sun, because I have to get a percent here, right? Yes?
Yes.
So my energy of the sun, they said that is 1 kilowatt per square meter. So I have 1.0 kilowatt per every meter squared. Would you agree that that's equal to 1,000 watts per meter squared?
I don't know.
What?
I don't know.
Yeah.
Would you agree, this is about to get crazy,
No.
that is equal to, this is going to make more sense to physics people, and you have to remember back to physics in freshman year.
Dude, nothing makes sense. Danny.
What is a watt? A watt is a what? A joule per second. So that also means that this is 1,000 joules over meter squared times seconds.
So then it's
Yes?
1,000 joules over 10,000 years.
Which is equal to 1.0 kilojoules over meters squared times seconds. That was not stoic. I was just saying this is equal to this, is equal to this, is equal to this. I just manipulated some units. Are you with me so far? I just changed units. Physics people should be with me. Freshman people haven't thought about joules per seconds in a while.
Yeah.
All right? We did. That was like electricity. We talked about joules per second as a watt. We're going to talk about that more at the end of the year.
Remember the light show?
The laser light show. That's a good day.
We had to put the night show already.
The what?
The ice show.
The dry ice show. That was my birthday.
That's right.
We did
Yeah.
we had to cover up the whole lab, remember?
Uh-huh.
That
That's a hard job for lab
that
aides.
was a job.
It's a big job. Okay. Lastly, how big is a hectare?
10,000 meters.
10,000 meters squared. So I have 10,000 meters squared. And I know that 1 meter squared second is equal to 1.0 kilojoules. You with me so far? Sure. Would you agree that there is also 1 minute in 60 seconds?
Oh, I got that one for real.
And there's also 1 hour is 60 minutes.
Oh, yes.
Oh yes.
Okay, good. So this cancels out hours. No, that does not cancel out hours. That cancels out minutes, cancels out seconds, cancels out meters squared. So this gives me kilojoules per hour. Yes? This is involved. 3.6 times 10 to the 7th kilojoules per hour.
I'm just gonna think about how I would have tried to.
Do you guys see this?
I wouldn't have ever.
Do I have a kilojoule per hour and a kilojoule per hour?
Yes.
Do we know that percent?
No, that one up there is perfect.
Which one?
Yeah.
Oh yeah, this is per hectare too.
What? No, it's not.
No, you need to add.
Kilojoules per hour. Wait, kilojoules per hour, kilojoules per hour,
The McDonald's no.
kilowatt, meter per squared.
Because you put 10,000 meters squared, right? You started out with 1 hectare worth of meters squared.
I mean, I guess it's like, it
Like it's there, but it's not.
Should we just trash the?
no, I mean, it's still going to be fine. Because a meter squared and a hectare are kind of, it's the same thing. It's the same thing. Percent equals part over total times 100. So I'm going to take the small one and divide it by the big one. So I have 3.3 times 10 to the 5th divided by 3.6 times 10 to the 7th times 100. You're going to be blown away by how efficient photosynthesis is. Well, what'd you get?
92.
That's what I got. 0.92%. That is why we need a lot of plants. Photosynthesis is less than 1% efficient. That's wild. It's wild.
Is that like the actual percent?
That's actually it. We actually solved it. We actually solved it.
Are we finally doing actual?
Is there better with more efficient ways though?
Is this real or not?
Is there more than this? Not that we found.
Is this fake chemistry?
This is actual chemistry.
This is like, you would never see something like this on any AP test or
That's what I love to hear.
That's what we like.
my
to hear.
test. But it's good to work through that, something like that. It's just good for your problem solving, good for your brain. Just to try it.
My brain, I think is more.
My hand hurts.
No, same.
My hand hurts.
Why did my shoulder feel? I'm writing.
Here's my 116. You guys want to see my 116 just to check your work? Okay. Oh, on 116, here's what I did. On 116, look what they gave me. They gave me FeO plus CO yields FeS plus CO2. Now, what I noticed on 116 is, are you guys looking at 116? If I didn't multiply this all by 6, Why 6? First of all, to start. What do I have a lot of in 116 in the steps they gave me? No. 2s and 3s. So I could have left this as is and worked in a lot of 2/3 and 3/2. Or I multiplied this all by 6, which made this math way better up here.
So you can kind of manipulate it.
You can, but then I had to remember at the end to divide by 6 to get the answer.
Okay.
So you could have left this and had a bunch of 3/2 and 2/3. You still would have got it, but this just made the math easier. So that's a good example for you to see on that. You still would have got the same answer. Still would have got the same answer. I think you got this too. Plus I'll give you an equation sheet.
I think we got this.
I think you got it.
Okay.
I think you got it. You know there's just going to be that one that you got to think a little more on.
I'm just waiting. I'm not gonna get too confident, but I'm,
I'm a believer.
I'm feeling better at it.
Yeah,
I kind of like got it, but then this just kind of like fills in the gaps.
that's the goal.
I just am glad I